Section 4, scale factor ratios with surface area and volume. So our goal is to find a scale factor still, just like we did in Section 3, but then apply it to surface area and volume, which is a unit issue. So if we take a look at this, you'll notice we will start with ratio of side lengths. So if we look at this picture, we will compare the corresponding sides here of 30 and 45. So we will say ratio of side lengths is 30 to 45. Now that's good enough, but as we talked about scale factor, we want it reduced, so this will come into play later. If I reduce that, I will get 2/3. But again, either one is right in the way they worded the question. The next one, what's the ratio of perimeters? Well, perimeter is distance around. So if this base is 40 here, then this is 40. If that's 30, then this is 30. If we add up the lengths there, basically it is 30 plus 30 plus 40 plus 40, and that means the perimeter of this shape is 144, or excuse me, 140. In the second shape, we have 60 above and below and 45 to the right and left. If we add up the perimeter for this one, again, distance around, I won't bore you with adding them up like I did the last one, I would just say 210. They want a ratio of perimeters, which means ours is going to be 140 to 210. And again, they don't say specifics of smaller to bigger or not, so this is fine. This will be appropriate. If we simplify it though and get the scale factor, it'd be interesting to notice that you get the same result. Conclusion being, ratio of side lengths and ratio of perimeters will be the same because they're both units of length. And that is a key to where we're going to go next. If we look at the next question, it changes. Find the area of each figure. Okay, to get a ratio of areas. Well, if you remember the formula for area, it's base times height, so 40 times 30. So the area of this shape is 1,200. In the next one, area would be equal to 60 times 45. So the area for this one is 2,700. So a ratio of areas would be 1,200 over 2,700. And again, they are not being specific about direction, so we'll just go small to big. Now, again, for scale factor, I'm going to reduce this. And if we reduce it, we get 4/9. Different than the ratio of lengths or ratio of perimeters. But that should be, there should be an obvious reason for that, and that is that area has units that are squared. We don't know what the units are in this case, but I know that if it was inches, I would square it. Lengths and perimeters would just be units, so meters, inches, and so on. All right, how do they compare? Okay, so we're going to compare ratios of sides and perimeters. Notice that was 2/3 and 2/3. They are the same. Okay, and that's because the units are the same. But sides and areas, well, that's different. That I would have 2/3 and I would have 4/9. Now, here's the interesting observation. Perimeter is regular units, area is squared. So if you take your regular scale factor and square it, you would get 4/9. So they are related in a sense that just taking your scale factor for length or perimeter, squaring it will give you the ratio of areas. Just an observation for further use. And this ends the scale factor, section 4, video 4, example 1.